Hello everyone, welcome to the R Masterclass lecture series, and in today's lecture we are going to look at the multivariate graphs. And in the last two lectures we have looked at how you could display a single variable graphs or a two variable graphs. Basically these two variables could be categorical variables or quantitative variables. And now most of the time what happen is we are most generally interested how you could display relationship among several other variables. So in the first lecture we looked at how you could display this univariate graphs, and we were able to make this graphs in R. Then we came up with the bivariate graphs, and we told we could have those two variables could be either categorical or a quantitative. Based on this, we have three categories in bivariate: categorical versus categorical. Then we have quantitative versus quantitative, and next we have categorical versus quantitative. And now it's time to look at how you could display the relationships between many other variables. So basically here you could see this is known as multivariate graphs, and this technique of displaying this graph is known as grouping. And we are going to look at what is grouping in just few seconds. But here you could see that we are displaying relationships among different variables. So here we have first variable as sex, then we have shows this relationships against rank, then we have year since PhD, then we have salary, and we could get an idea of what is the relationships among uh, each variable compared to the other variable. So we could plot, okay, year since, how many experience does the professor have, and then we could see the salary. We could also see that we could also plot the rank, okay, which rank has highest salary, and then we could also see the relationship of gender that among the other variables what it have. So basically circle is for female and triangle is for male, and here you could see generally male have higher kind of salary. So you could find lot of intuition behind these graphs. So now let us see what is multivariate graphs. Basically multivariate graphs displays the relationships among three or more variables, and basically there are two common methods for displaying the multivariate graphs is grouping and pasting. So we will look on to this what is grouping, and then we are going to look at what is pasting. So what is grouping? In grouping, the first step is to map the main two variables into the x-axis and y-axis. Then the additional variables are mapped to the characteristics of the graph. So could be mapped onto the color, it could be mapped onto the size, it could be mapped onto the shapes, onto the data set. So basically in what happen in grouping is we group first plot x and y, and then we plot the rest variables onto the visual characteristics of the graphs. And here is the general definition. In grouping, the value of the first two variables are mapped to the x and y axis. Then the remaining additional variables are mapped to the visual characteristics. So this could be color, shape, size, or line, and transparency. And this allows you to plot the data for multiple groups in a single graphs. Now let us see example of our multivariate graphs, how you could plot it. So basically in lecture second of data visualization, we looked at the bivariate graphs, and in bivariate graphs we looked at the quantitative versus quantitative graph displaying, and in this we looked at our scatter plot, and we have come across this plot. So to make this a multivariate, what we could do is we could do make a change the characteristic of the color and show that in this we could show this, we could add one more variable rank to this graph. So what we could do is basically through the color representation we have added one more variable for our data visualization to show the graph. So we are displaying the assistant rank, then we are showing the associate professor, then we are showing the professor through the color characteristics of the graphs. Now what we could do is we could add one more variable to it. We could add gender to this characteristic by displaying the shape of the graph. So by adding a shape to this graph, we have also displayed the gender of this graph. Basically, if it's a circle, it's a female, and if it's a triangle, we could see it's a male. And you could try to interpret a lot of things. Here you could see that generally the male have higher salary, and you could also see that also generally um there is no trend for similarly there is trend that male also have less salary, and you could also see that generally there is a increase in tending to increase in salary of female. There is no disproportion yet. Now let us see how you could plot this in R. Before moving on to the graph section, we should look at our data set, and you have already come across this data set, that is salaries for professor. In this we have format of the data, which we have column of rank, discipline, experience, service, gender, salary in this graph. So what we are going to do is basically plot experience versus salary. And if you remember, how did we plot this is in our lecture 2. We have already plot this using through scatter plot. So you could try to attempt by yourself to plot a scatter plot against years since PhD and a salary. If you weren't able to, you could play this video, or you could else pause this video and try it by yourself. As our general method, we remove all the data variables. We remove it. We remove clear our console. We need know the shortcut, that is Control L. Now what we are going to do is we are going to import our favorite library, that is ggplot2. So we are going to say library. Then please import our favorite library, that is ggplot2. Then once we have imported our data set, we need to import once we have imported our library, we need to import our data set. And to import that, we call data. Then we say salaries that we need to import, and this is under package is equal to in our car data, which is our package. And if I save it, let us save this file, our plot, and once we run it, we get the salaries of 397 observation. Now once we have got an idea what our data set is, we are going to plot it. So to plot this, we are going to say ggplot, and then we need to first provide our data. Here you could see in the suggestion that first you need to provide data, then you need to provide aesthetics, and then if you want to provide any other environment tags to it, you could provide it. So we don't have to look onto the environment thing, so we just going to provide our data first, salaries, and the mapping we could say aesthetics. In our X it would be years since PhD, that is our experience. And then we are going to say that in our Y, could you plot us the salary. So here we got the main idea what we are going to plot. Then in the next thing we could say geom point, and basically geom point is the scatter plot. And if we run it, we know the shortcut, that is Control Shift Enter, and if we run it, uh, we get our scatter plot. Now what we could do is we could add a tag to it, that is using labs, and we know we could add the title by typing title and then providing a title to it. So academic salary by years since degree. And then we could also say that our X represents the experience, and based on that the salary is y. You could say that. And here, save it. We get our academic salary by years since experience. So what we could do is we could add one more parameter to it, that is through color could we add the rank to it. And to do this you just need to provide one more parameter to our aesthetics, and we just need to mention that through color represent or one more variable, data variable, that is rank, which is basically the uh, rank association, like rank association of the professor. So this could be a professor, or if he is assistant professor, or is he or she is a associate professor. So we could do this by doing a simple method, just going to our aesthetics, and here we could mention that through color represent our rank. We save it, run it, we get our rank by data visual. We get our rank shown in our previously a bivariant graph. Now it has been converted into the multivariate graphs. Now you could see that the blue color is for professor, the green color is for our associate professor. We could also see that the red is for assistant professor. Now let us do one more thing. So we could say uh, we could add one more variable. If we want to add, we could add one more variable to it by adding a shape tag to it. So we could add a shape to it showing that uh, if it's he is a male or female professor. Basically, we could pass the sex to it, and then our ggplot2 will handle all other thing to the mapping. So we could do is basically we could say shape is equal to sex basically, and then we could run it. We get our plot, and here you could see that our plot size is very difficult to read. Basically those triangles are very small, so we could increase the point to it. So we could say size to it is 3, and we could add a alpha tag, which is a transparency tag, to it, and I like 0.8. uh, it's my general choice, it's up to you how much transparent you want, and you could get your plot. And it's much, I need much more transparency, so I'm going it to 0.6 because it's much more. Yeah, now it's looking okay. And here we get our one more data variable represented through the data visualization. What we could do is we have plotted our graph. So basically what we could do is we could add a quadratic line, basically best fitted line, to this or plot. So to add this we could add a geom smooth parameter to it called geom smooth. We say then if we want to have the upper band lower band in quadratic line, we could provide the value SE to be true, or we could keep it false. So for initially we could keep it false, and for the demo purposes I will make it true. Once we plot it, basically it shows the upper band and lower band in which the line lies. So method we are going to use, then we need to provide the method, and method we are going to use is our favorite model that we know, linear model, and then we need to provide a formula. So basically the formula we are going to use is the quadratic equation, then we call y x poly, and then which uh, then the x parameter we need to provide, and which degree do we need to use. So we are going to use second degree, that is quadratic. And then if we need to provide the size of our line, we could provide it by the size tag, and it will keep the line at that size only. So let us run it. we get our line, and here you could see the associate professor line, um, assistant professor line, and then associate professor. Since this line doesn't, we are able to get too much into it, we could not interpret much thing. So what we are going to do is we're going to fix this. So we are going to remove, first thing, that we don't need size regarding our service, and basically we could say the shape, we don't need shape tag also, we are going to keep it very simple. And then regarding the color, we could keep it to be the gender. So we could see, let's see that if male student, male professor is earning more or female professor earning more. So we could see, and here we get the graph, and in this we could see that from range 0 to 40 there is a general increase, but for male professors this isn't the case scenario. Initially they earn more, and then they have less salary also, you could see in this. Now we have looked at what is grouping is. Now it's time to look onto the what is fasting. Now it's time to look at what is fasting is. Basically in grouping we see that we plot each variable, and other variable that we want to plot, we plot against its visual characteristics such as color, shape and size. So in salaries function we looked at how you could plot different graphs. Here we could see we plotted different graph, salary versus experience, and then we plotted rest of the data based on the data visualization, based on the graph visualization that we have. So basically we plot it against the color of the graph, then we plot against the size and then the shape. But in fasting we have different concepts. So for each graph consists a separate plot or a small multiplied plot for each level of a third variable, or we could have a combination of two. So it's best to look at the example. So here we have a count and salary, and for third variable, that is rank, we have each different plot for each variable. So for professor we have different plot, because associate professor we have different plot, for assistant professor we have different plot. Similarly, for we could have a combination of two, for male and female we have different graphs for each variable of graph. So for assistant professor we have graph for female, then we have one for it male. Then for similarly we have associate professor graph for female, then we have for it male. For professor we have for female, then we have it for male. Now let us look at how you could plot this, and basically we are going to use the similar data, that is our salaries. So here's our data, and for grouping we have also looked at the data set. We are going to use the simple this data set only. So now let us open our R visualization plot, and let's see how we could plot this. So to plot this we are going to first clear our console, uh, control L, then we click on this pruning button which will clear our variables. Now let us see how you could plot this. So first we will import our favorite library. So library, and then we say ggplot2. Then we call our data. We'll say we need to import our so first we will import our salary, ggplot2. So first we will need to import our library, that is ggplot2. Then we need to import our data, that is inside salaries, which is inside the package card data. Once we have imported our data card data, we need to plot it. So we'll say ggplot, please plot our data. So we'll provide the data to plot it against his or salaries. And in aesthetics, we need to say we want to plot our salary. So we will say x is equal to salary. And for the y, we need to have fasting. So we will get automatically, we will not define the y parameter, it will automatically take the count of it. So we don't have to worry about that. We'll say we need to plot a histogram in the pasting, and which will plot salary, and the y-axis would be our count of that. And since we need to have it multivariable, we need to have a pasting type. So we are going to call facet trap, and in this we are going to define the rank needs to be plot, and in number of column we need only one. So we'll say 1, and then let us see what we have got. We got our professor rank, assistant professor rank, and then the count of in the y. What we could do is, one more thing is, we could add labels to it by calling labels, and we could provide title and say the title is salary histogram by rank, and we could get our plot. Now what we could do is, basically we could add one more parameter to it. And before we add one more parameter, let us see. So we could see that the count for assistant professor is much more. Like you could see, general count highest is 30, and then we have lowest count for associate professor, then we have it for the assistant professor. Now what we could do is, we could add one more group of variables into it. So we could add one more parameter to it, and we could map it against also the gender of the professor. So we could say sex, and then we could plot it against, we get the plot. But what happening right now is, the salary is too big that it needs to be divided by 1000. So we need to divide it, because the salary is way better, and once we plot it, we are not getting the desired result. Yep. So number of column needs to be removed for this. There's general one error, because if we have number of column 1, then both are plotting against each other in the same column, and that's we don't want it. So we'll save it and then run it. We get our ranking against male professor and female professor. So female assistant professor, we have this, then we have female associate professor, then we have female professor, then we have also male assistant professor, male associate professor, male professor, by the combination of the two variable, that is sex and rank. So now what we are going to do is, our task assignment is to plot a graph, pasting graph, in which we will plot gap minded data. In this, for this we are going to use continent and plot the life expectancy for this. So we need to plot the change in life expectancy. In this we need to plot x, which will be our year, then y would be our life expectancy, and then we need to do this for each country in the continent Asia. So you could try to attempt by yourself, else you could pause this video and we will solve this. So first what we need to do is, we need to clear our console code, and then we'll remove all our data variables, we'll remove our data plots, we'll clear our console. Now if you remember, we'll need to use dplyr package to get the data from the to get the life expectancy of each country from the continent Asia. So for data manipulation, our favorite library package is dplyr. So first we'll import our main library, that is ggplot. Then once we have imported, next favorite library is that we need is dplyr. Why? Because we need to have the data manipulation for each continent. We need to get the life expectancy. So for this data manipulation in gap minded data set, we need to use dplyr package for the data transformation. Before that, we need to import our data. So we'll import gapminder, the data, and it's inside the package gapminder. We'll save it, we'll run it. It's saying Gapminder is not defined because here is what typo. So we'll fix it, we'll run it again. We get our data set, we get 1704 data entries, and based on this we need to get only the data set for the continent Asia. So we'll say plot data, and in this we could say dplyr, and from this we need to call the function filter, and then we are going to filter data, that is Gapminder, and then what we need to do is continent, which the continent is or Asia. Let's see what we have. We have got 396 observation for the data set for the continent Asia. Now what we need to do is we need to plot each plot for the life expectancy and the year for each country in the continent Asia. So we'll say ggplot, and then we need to pass our data. We'll say plot data, or aesthetics in X would be our year. Then for Y we need to provide the Y parameter, which is life expectancy, and then we first could plot this. So we need to provide what we need to plot. So we could plot it through geometric line, basically to plot the line, like if it's increasing or decreasing. It's saying the ggplot is not defined, so we'll fix this error by entering this, and we get the plot for this, but it's for each country continents, and it's very much terrible that we could not understand anything inside this, because it's increasing, then decreasing, and then increasing, decreasing, because of the each country starts their plot increase and then they decrease. So you could see how much bad it is to directly plot. So we are going to use the thing pasting. So first we need to say we need to provide geom point, basically the point that is inside the geom line to point it, and we could provide a color to it. We could provide our color, it could be cornflower blue, and then what we need to do is we need to face trap. So we need to call method face trap, and in this we could add this into new line, and we need to provide it through the country, basically plot it against the country. We need to plot it each plot. So we are going to check it what we have got, and we have got our data set. And now what we could do is we could add a theme to it for better thing. So we are going to use theme minimal, and it have itself parameter. So basically to fix those color, the text size, they have the parameters already defined into it, and you could see that we have got our plot, and it's a very big plot although. So what we are going to do is we could um, also add labels to it. So first we'll say need tab labels, and title is going to change in life expectancy and and Y would be our life expectancy. We double quote it, and then we say X is equal to and then we save it, and then we run it. We get our package. Now here's a challenge for you. What you need to do is fix the y plot and the x-axis plot. And if you remember, we have to use the adjacent method, that in which we plotted by 45-degree angle. So it could almost plot everything in it. So here's a task assignment for you. Hopefully you could fix those. So now you could pause the video and try to attempt by yourself. Else, let us see the answer. So first we need to call theme method for this, and then we call axis dot text dot x axis we need to get, and then we call the element text that needs to be fixed, angle by 45, and then we just need to adjust it by 1. We run it, we get much more readable values. And here you could see that for every data set it's increasing, except Cambodia. It have generally the life expectancy have decreased. Let us make it full screen, and the data plot gets adjusted by itself only. So if we run enter again, yeah, so here we get the value that we could see that there is general decrease in Cambodia. There was also generally decrease in China itself in 1960 to 1970s, but then there is overall increase. For India, it's increasing as well. For other countries, it's always increasing. For Iraq, it's decreased from 1919, but then it's slightly increased. And for other country as well, there is general increase in overall life expectancy. So now we have looked at how you could plot the multivariate graphs. In previous lectures, we have looked at how you could plot uh, bivariant and univariant graphs. And in this lecture, you have looked at two methods how you could plot the multivariate graph, that is grouping and pasting. We looked at what is grouping is, that we plot each variable through their characteristics in the graphs, and in pasting we plot the graphs, but for each other data variable we have different plots. So similarly in this you could see that for a country in Asia we have different plots. Now in the next lecture we are going to look at the different methods of the graph. So we have map plots. We are going to look at the map plots in the next lecture, and with this I hope to see you on to the next lecture. Thank you everyone.